Hello students, welcome to my channel. Let's revise with Babita. This is the second module of chapter solution. So let's start now. Our topic we have done is expressing concentration of solutions. As you know, we already have done molarity and normality. Now there are some relations. So first relation is relationship between normality and molarity, right? As you know, normality of a solution is equal to molarity into molecular mass upon equivalent mass, and normality of an acid is equal to molarity into basicity. Normality of a base is equal to molarity into acidity. For example, if we have to calculate the normality of H2SO4, and you know H2SO4 contains two H positive ions. So normality of H2SO4 is equal to 2 into molarity of H2SO4, right? Now we have relationships. That's our first relation is relationship between volume and normality or molarity of a solution, right? We have first equation. That equation is known as normality equation. If we have two solutions, one having volume V1 milliliter and its normality is N1, it reacts exactly with V2 milliliter of solution of normality N2. Then we have the relation N1 into V1 is equal to N2 into V2, and this equation is known as normality equation. Similarly, we have another equation. That equation is known as molarity equation. Similarly, we have again two solutions, one having volume V1 and its molarity is M1, and are diluted to another solution of volume V2 milliliter, and the molarity of the diluted solution is M2. Then we have an equation M1 into V1 is equal to M2 into V2. This is known as molarity equation. Now we have the last topic of concentrations, that is ppm, that's parts per million parts. We have if we have 1 glass of water and we are adding only a single drop of ink. That means when a very small quantity of a solute is present in a large quantity of a solution and the concentration of the solution is expressed in terms of ppm, that's parts per millions. So it's defined as the mass of the solute present in 1 million parts by mass of the solution. Thus for a solute A, we can calculate ppm. ppm of A is equal to mass of A upon mass of solution into 10 raised to power 6. Now students, we have done all the topics of concentrations. Here are the numerical sum, and this is specially taken from NCERT, and I hope you all of you are doing the questions from NCERT book. Here is one example. Calculate the mole fraction of ethylene glycol in a solution containing 20% of C2H6O2 by mass, right? So we have one is solute and another is solvent, right? Assume that we have 100 grams of solution. One can start with any amount of solution because the results obtained will be the same. Solution will contain 20 grams of ethylene glycol. C2H6O2 is the formula for ethylene glycol, and 80 grams of water. That means 80 grams of water is the solvent and 20 grams of ethylene glycol is your solute. So molar mass, you know how we calculate molar mass, it's equal to 62. Number of moles is calculated by using the formula weight in grams upon molecular mass, right? So it is 20 upon 62, that's equal to 0.322 mole. Similarly, if we have to calculate moles of water, that is 80 upon 18, because 18 is the molecular mass of water, then it is equal to 4.444 moles. And now we have to calculate mole fraction of ethylene glycol. And as you know, mole fraction is equal to number of moles of the component divided by total number of moles of the solution. So it is 0.322 upon 0.322 plus 4.44. That's equal to 0.068. And similarly, mole fraction of water is calculated number of moles of water divided by total number of moles of the solution, that is 0.932. And as we have already done, and we all know that the sum total of the mole fraction is always equal to 1, right? So mole fraction of water can also be calculated as 1 minus 0.068, that's equal to 0.932, right? This is another numerical I have taken from the NCERT book. Calculate the molarity of a solution containing 5 grams of NaOH solution. Right? I hope you can solve it now, because you know moles of NaOH is equal to 5 grams, that is given to you, and molecular mass you can calculate NaOH, that is 23 plus 16 plus 1, that's equal to 40. Volume is given, and then molarity is equal to, using the formula for molarity you can easily calculate it. Another numerical again from NCERT, calculate molality of 2.5 grams of ethanoic acid in 75 grams of benzene. You know, in molality, the formula is a number of moles of solute divided by weight in grams of solvent. So here our solvent is 75 grams and we have weight in grams of solute, that is 2.5 grams. But for calculating number of moles, we use the formula weight in grams upon molecular mass, that is 2.5 upon 60. This is the moles of this is the moles of ethanoic acid, and mass of benzene in kilogram is 75 upon 1000, that's 75 into 10 raised to minus 3 grams, and molality of ethylene glycol, that is mole of ethylene glycol upon kilograms of benzene, then it is equal to 0.556, right? This is intext question, and I hope you all will solve these questions. You try to solve these questions. Now, another topic is our solubility, right? This is the next topic of your chapter solution. Solubility. The solubility of a solid in a liquid at any temperature is defined as the maximum amount of the solute in grams, which can dissolve in 100 grams of the liquid solvent to form the saturated solution at that particular temperature. You know, when we dissolve sugar in water, it dissolves. That is solubility. Solubility of a solid in liquids, right? A solute dissolves in a solvent if the intermolecular interactions are similar in them, that is, like dissolves like. Polar solutes dissolves in polar solvents. It's a very important point to remember. Polar solvents and non-polar solute in non-polar solvent. For example, sodium chloride and sugar dissolves readily in water, and naphthalene and anthracene dissolves readily in benzene. It's not necessary that every solute and solvent mixes. So we have to see the property of like dissolve like. This is a diagram in which we have positive and negative ions. Negative will attract with positive and positive will attract with negative, because in ionic compounds we have Na positive, Cl negative. This is one example. Now we have dissolution. When a solid solute is added to a solvent, some solute dissolves and its concentration increases in solution. This process is called dissolution, right? And we all know that we have done the practical on the basis of crystallization. We have another topic, crystallization. Some solute particles collide with solid solute particles in a solution and get separated out. This process is called crystallization. For example, copper sulfate that we have already done in practicals. At this stage, saturation point is reached when both processes occur at same rate. A dynamic equilibrium is reached. That is, solute plus solvent gives you solution. Now, point is, what is a saturated solution? A solution in which no more solute can be dissolved at same temperature and pressure is called saturated solution. That is, concentration of solute remains constant. Now another is unsaturated solutions. Solution in which more solute can be dissolved at same temperature and pressure, right? That is known as unsaturated solution. Supersaturated solution, when more solute can be dissolved at high temperature in a saturated solution, the solution becomes supersaturated solution, right? Now we have another point. Sixth point is effect of pressure. Solids and liquids are highly incompressible. So pressure does not have any significant effect on solubility of solids and liquids, right? And a very important point is effect of temperature. In general, if in a nearly saturated solution, the dissolution process is endothermic, that is delta H, delta H, that is enthalpy, change in enthalpy. Change in enthalpy of solution is greater than 0. The solubility should increase with rise in temperature. If it is exothermic, delta H sol, that is enthalpy of solution, is less than 0. The solubility should decrease with rise in temperature. Now we have a very important point, another point, that is solubility of a gas in liquid, right? All gases are soluble in water as well as in other liquids to a greater or lesser extent. The solubility of a gas in liquid depends upon the following factors. One is nature of the gas, nature of solvent, temperature, and pressure. Generally the gases which can be easily liquefied are more soluble in common solvents. Example, carbon dioxide is more soluble than hydrogen or oxygen in water, right? The gases which are capable of forming ions in aqueous solution are much more soluble in water than other solvents. For example, HCl and NH3 are highly soluble in water but not in organic solvents like benzene, in which they do not ionize. Thank you.